Welcome to Flip Lesson 102 for the 5th grade. And today we are looking at subtracting decimals, especially when we're subtracting and there's some place values missing and we got to add in some zeros and how to deal with that. All right, let's go right into it and try some of these sample problems together. It says, I don't know what this is saying. I don't know why it says the there. Let's just erase that real quick. Johnny's tablet uploaded the file in 2.3 seconds. Chachi's tablet uploaded the file in 0.135 seconds faster. How long did it take Chachi's tablet to upload the file? All right, so we're going to take this idea, right? We have 2.3 seconds. So I'm going to say 2.3. And I'm going to subtract 0.35, right? Now I definitely have to line up my decimals, so I'm going to do that first. Okay, now I got my decimals in line. Now I can start plugging in my values. I got a 0, I got a 1, I got a 3, and I got a 5. All right, and now we're going to subtract. Now, the common mistake that many people make is they just say, okay, I can put the 5 down, I can put the 3 down, and then I can subtract 3 minus 2, and just like that, I am done. However, that is not true. Remember in the last lesson we talked about sometimes we hide those extra zeros, those zeros that we don't really need to understand the number. However, sometimes we need to put those zeros back in so that we can correctly do the math, right? So as we look at 2.3, we need to add a 0 in here and a 0 in here so that our place values are all matched up. And now we have a very different kind of problem. We have 0 minus 5. And right away you're going to say, wait, you can't take 5 away from 0. If you have 0, you can't take 5 away. So we're going to have to borrow, all right? And we're going to borrow, and we're going to end up borrowing all the way over to here. And so this 3 is going to become a 2. This becomes a 10, and we borrow from that right away. And so this becomes a 10, and this is a 9, right? Now I'm getting up into my words. But now we can subtract, right? 10 minus 5 gives us a 5. 9 minus 3 gives us a 6. 2 minus 1 gives us a 1. Decimal goes straight down, and the 2 goes there. Add my label, and voila! I have my problem solved, right? But I needed those extra zeros to do it correctly. Let's try another one. Elena walks 7 miles every day. Her pedometer records how far she walks. While walking on Saturday, Elena looks down at her pedometer, which reads 2.65 miles. How much further does Elena still need to walk? All right, so I start with my idea. I have 7, right? And I'm going to do 2.65 miles, right? I've already walked that much. She's already walked that much, not me. And so we're going to subtract that amount. Okay. However, 7 doesn't have a decimal, but we understand that 7 really means 7.0 miles. So I'm going to write that like that, just so I have a decimal, so I can line up my decimals. All right. But even with adding that 1 0 here, I realized that, wait, I don't have anything to match here, so I actually have to add a second 0 there before I can go and solve. But now I can solve, right? 0, 5 can't be subtracted from 0. All right, so I'm going to borrow. This is going to become 6, right? This is going to end up being 9, and this is going to end up being 10, right? 10 minus 5 gives us a 5. 9 minus 6 gives us a 3. Decimal goes straight down. 6 minus 2 equals 4. So in the end, she has 4.35 miles still to walk. Lucky her. All right, so we have that idea. All right, we're going to end part 1 of the video here. Come back in just a minute for part 2. All right, this is part 2. We continue looking at, and here we have a unique problem, right? It says the land area of Seattle is 142.51 square miles. The land area of Olympia is 18.43 square miles. Well, how much greater is the land area of Seattle? Now, a key word right here that should jump out at you is we start with the word about. And because we start with the word about, we want to do some rounding to get us started. And to do some rounding to get us started, we're going to take our numbers, right? And we want to round The easiest way to do this is round to the nearest whole number. So if we're looking at this figure right here, we're going to say, okay, I'm going to round to the nearest whole number. So there's my place value. I'm looking back 1, and that's a 5, so that says round up. So I'm going to go to 143. Right? I write my second number. Right? Round to the nearest whole number. Look back 1, that's a 4. That says round down, so it's going to stay 18. So in the end, the problem that I'm left with is 143 minus 18. Right? And I can take this 18 and I'll shift it over here. Everything's lined up real nice, and now I can subtract it. And so we have 3 minus 8, can't do that, so I'm going to borrow here. That becomes 13. This becomes 13. Wow. 13 minus 8 gives us a 5. 13 minus 1 gives us a 12. Right? And so we have that idea there. And so in the end, the difference is 125 square miles. And so sometimes, even though we've been working with decimals and subtracting decimals, we want to make sure that we read the problem correctly so that we do exactly what it tells us to do. In this case, it told us to estimate before we even subtract. All right, here is a sample problem to get you on your way then as you work with lesson 102, subtracting decimals.